everyone. Just wanted to make a video about the new Python API that we have now in EikoTwin DIC. First of all, before going through the features and the functions of this API, just want to remind you that you have, as always, access to the manual here in the About part of the menu. And by clicking on User Manual, you will end up opening this this PDF manual. And now, as obviously you have a new version of the manual that is even more complete than before, but now you have a section which is 3.3.8, which is about the Python API that we now have. And so, yeah, it starts here. And it will give you a whole description of all of the functions that we have and how to use them. Should be complete, but feel free to tell us about something that is unclear or that we should modify. But you can find all the details of what I'm going to talk about in the manual. So first of all, I'm going to start with just showing you the main functions that we have here in the Python API that are most of them are in this file, I would say. So you, thanks to this API, you will be able to create new sensors, to create new user fields, and obviously, thanks to Python, to operate on these quantities in order to, calculate whatever you need from the results that you get from the AC. So here, for instance, the first things that we are doing is adding sensors. To add a sensor, you need to define their position, their orientation. So this is what we're doing here. So it's pretty straightforward to define the position and to give it to the add sensor function here. So then you have a possibility to display all of the sensors that you have. So you can just get the sensors and print the list of names. You can obviously remove a sensor as well. You can just remove a user sensor, user-defined sensor, and not a sensor that was created in the interface to avoid any problems with that. You can remove it either by name or by ID. You can get a gist of what happened if something went wrong. You have a lot of information about the errors that you will get. And obviously, when you added the sensor, you can then fill it with information that you calculated. So for instance, next I will show you how to create a crack opening displacement sensor. And in this case, you can add the data directly to the sensor. So you have a bunch of options that, again, you will find in the manual to how to create to write the right formats to this add sensor data function. So this is for the sensors. You can remove also the data from the sensors, but you can, well, basically access and create and delete some of that information. This is for the sensor part, and then you have all of the mesh part. So you can get the mesh from a DAC project. You can read displacement fields, so get the nodal displacements. You can add a new displacement, that is a new field, that can be created from, basically any kind of procedure that you like, but here we just put the displacement back into a field called myField, and then sending this field to the database with set nodal user field. You can obviously get them back and read them and delete them as well. So what can you do with these functions? You might already have ideas, actually. The first idea that we had was to adapt one of the scripts that we had for crack propagation monitoring. So I have this project here about a crack opening, which is something that we have, admittedly, maybe a lot of images, maybe too much images, but the test here is what's called the double cantilever beam test, which is pretty common in the field of composite materials, to evaluate fracture toughness in mode 1. And so we painted this, we aligned the mesh to the image as we always do. This is a projection step, so it's a 2D example here. We had marks here to align the mesh to the images, and we knew what was the dimension of the mesh. So we knew exactly where the crack is supposed to happen, because it's basically between those two crack arms, I'd say here. And so we measured the displacement, and here I didn't measure everything. I just measured 1 every 10 images because we didn't really need that to have the full field, but you could have that obviously. And so when you move, let's say I want to move to the next one. Here, for instance, I have a field for all of these. I can also look at the profile, what happened when it's really open like that, and you might see that if I move every 10 images, you get a new displacement field, and the crack moves along in the X direction here. So how to process that? We have measured the field, but we don't necessarily know where the crack is. So we have here in the Python script, we've adapted a procedure where we would measure the opening for every, I think it's every node or every millimeter of the beams here. We put a displacement sensor. You won't see it in the interface because it's no use to create all of these sensors, but we basically measure the opening between those two arms here for each of these nodes. And this way we are able to follow along, because we say that if the opening is above a certain threshold, usually you take the uncertainty or 3 times the uncertainty in displacement, it means that those arms have separated and the crack has passed between those two arms. And this is something that is a pretty simple criteria, but it works pretty well. So here I've done the script. I've adapted the functions here to solve that problem. So I've fixed this threshold, as I've said. This is the maximum number of steps that I have in the database. So I'm just going to run you through the script and explain what I'm doing. This script is available if you need it. I'm just not going to go to every function, but just basically telling you the steps and where I use the API functions. So the first location where I use it is the get mesh. I just want to get the mesh geometry, find the nodes of the upper and lower arms, thanks to just their location in the XY plane. I define the nodes in the central line of each of these arms, and then I'm just going to sort the nodes by X coordinate, meaning I know basically in what direction to get through them when I do the test with the threshold. So this is just basically getting information from the mesh geometry. Then I create a user sensor that I'm going to call crack opening displacement. This is just, I just want to draw this information, so I have to have a sensor. I just put it at 0, 0, 0. It's just going to be a dot. It's not going to be useful that it's a specific position. It's just located there. Again, for the dimension and orientation, it doesn't change much in this case, but I just have to define that. So I'm creating that sensor, removing it in case it exists, and then creating it, and with all of these options here. Then I initialize the crack length to not a number, because if I don't have any crack, I don't want it to be 0 to be a certain value. I just want to be a not a number, for it not to appear in the plot, because at step, if I go back to image 1, I don't have a crack that's opened at this stage. It's opened around here, and then it's going to come in and then go through the sample. So I don't really need to have a certain value for the crack opening displacement at the beginning. I don't really know what the crack location is. Yeah, so I'm actually I just realized that it's not a crack opening displacement that I'm measuring here. It's a crack length. I'm just going to change that so that it reflects in the sensor name. Sorry for that mistake. Okay, so now I've created that, initialized, and then I'm going to calculate my crack length and preparing the data. So I'm getting the nodal displacement because I want to measure the opening between those two arms. And then I'm going to see if that opening that I'm calculating thanks to the displacement of the upper arm and the lower arm, that opening has reached a certain value that is higher than the threshold. So if it's the case, I'm going to set my current crack length to X, which is the value of the node, the location of the node that I'm at. I could interpolate as well. I chose not to do that here, but I could just interpolate if that's I need a finer resolution. This is something that we've done in the past as well. Okay, so just updating the value and then creating a data point for my sensor. And for each of these data points, I need to specify what time I'm at. And the value obviously that I'm going to put in the data point. So I just add that data point to the data's file, vector. When I have finished my loop, I will just have every data in memory. So I just need to write that to the sensor now that exists. So again, crack length, and yeah, we'll be done. So I'm just saving that. The way I'm running these scripts here through the interface is in the displacement, or I think also in the sensor, probably also in the sensor tab. I can open the Python console, and you see here that there's no sensor for the moment. And what I'm going to do is just copy paste the code that I've written here directly to the console, and just here I'm just going to make it a little bit bigger for you to read what happens, and that's it. So at the beginning it's not a number, and then if the crack happens to appear in the DIC field, it's going to be measured, and we are going to have a crack length. So again, now I have a crack length that's precise at 0.5 millimeter close, because this is the size of my elements. And now it tells me that everything's finished and that the sensor data has been added to the database. So let's look at that. I do have a sensor here. That's the right name now. And I have all the data in memory, so I'm in my graph here, and I'm just going to display all of the values that I measured. So you see here, I'm just going through the data, and I can then either plot this versus false, or I can just export this back, or I can just keep it in memory and look at it in front of other kind of data. Yeah, so you see this is a pretty straightforward. When you know how to use the functions and you know a little bit of Python, it's not really very complicated, so you can imagine a lot of processing by yourself. So yeah, I'd like to know what you're doing with the interface. We'd like to know more about your ideas and projects. We can even think about building a database with all these scripts that maybe can help other users. So feel free to reach out and tell us what you did with it. We'll be happy to help maybe developing, and obviously if you need any help with using the functions of the API, you can just reach out as well. Thanks for watching, and feel free to answer in the comments or send us an email if you need help. Bye bye.